Thank you so much for the invitation to talk and follow the rollout of the CIB roadmap. I'm happy to discuss the perspective in the United States and North America. As Mimu mentioned, I work for the National Institute of Standards and Technology. We're part of the United States Department of Commerce in the U.S. federal government. I'll cover a couple areas this morning that I think are relevant to the CIB roadmap. Mimu already has mentioned cyber-physical systems, which includes the concepts of the Internet of Things. We've had a public working group looking at that area, and it's developed a draft framework, and there's some parallels with the CIB roadmap that I'd like to mention. Then I'd also like to cover the growing interest and support for smart cities, both in North America as well as the rest of the world. We have our President of the White House interested in smart cities. There's a White House Smart Cities Initiative, of which our own activities, the Global Cities Teams Challenge, is part of. And then we have a new effort that is starting, a new international working group looking at Internet of Things enabled smart cities and developing a framework for that, which I think will be of interest to the audience. Let me start with cyber-physical systems, also including Internet of Things. We've had a public working group composed of experts from industry, academia, and government working together to develop the foundation for cyber-physical systems. This effort, there's a website that's listed here where you can find all of the material. This effort has produced a framework, a draft framework, a technical foundation of concepts for cyber-physical systems, which underlies smart cities. And we're currently revising the framework based on public review comments. In the upper right, you'll see that cyber-physical systems combine the cyber and physical components in an information, decision, action, and physical state loop that can be both at the system level, you can dive into components at the device level, or you could be broader with the systems of systems concepts, and that these interactions that form these cyber-physical systems also, very importantly, include human interactions. Overall, this process has revealed a way to understand the system engineering process. If you think in terms of facets, it's a word that we've devised to span that cyber-physical system development process. And there's three key facets. There's the conceptualization facet, where you are understanding the requirements of what you're trying to design. You're producing a model for how the cyber-physical system will work. In the realization facet, that's where you're making the trade-offs, the design trade-offs, and producing the actual cyber-physical system and doing testing and making sure that it will operate correctly. And then also there's an assurance facet, which is sometimes overlooked but is also very important. You, in many cases, will need to assure the public or the folks purchasing your cyber-physical systems that you have realized the actual working system and its properties map onto what you had conceptualized them to be. So it's kind of like the proof that you've done the work that you have claimed to do. This facets is a collection of activities and the results of those activities. So that's why I mean it spans the system engineering process. But at the same time, you're going to have many different stakeholders and domains. Those domains and stakeholders will have concerns. Those concerns are going to need to be addressed throughout the system engineering process. That's where we have the concept of aspects. So these are collections of concerns in the areas listed here: functional, business, human, trustworthiness, timing, data, boundaries, composition, and life cycle. These collections of concerns need to be addressed at all parts of the system engineering process. So in each of the facets, conceptualization, realization, and assurance, you're going to have those concerns identified and addressed. Their properties either then will be made provable through the assurance activities. One particular aspect or cluster of concerns I want to point out is trustworthiness. We had a subgroup that was composed of cybersecurity and privacy experts, and they identified an even broader concept of trustworthiness, where you want cyber-physical systems that you can rely on, and these are going to need to have security, privacy, safety, resiliency, and reliability all together to make something that you can rely on. One of the interesting things is that each of these areas has a risk management strategy and approach, and it's this combined risk management approach that's going to be necessary to produce systems that are trustworthy. So let me very quickly look at the alignment of concepts. Mimu did an excellent job of describing some of the key components of the CIB roadmap and some of the concepts, the cross-cutting concepts. And I want to show you here that there's a lot of similarity and overlap with this work. So this is very good. This is showing that we're having thinking that is aligned between our different activities. The CIB roadmap revealed the importance of digitalization. In the CPS framework, we talk about information technology coming together with operational technology, but both of these are enabling new services and innovation. In the CIB roadmap, there's integrated planning and management. This is very important, and one of the goals of our cyber-physical system framework is to enable integration at multiple scales. I mentioned devices to system of systems, and the planning portion of it, there's a lot of interest in co-design, being able to engineer these systems. A lot of that is found in the conceptualization facet, where you have a model of the cyber-physical system. Again, we both have stakeholders, and we have domains and concerns that are organized into aspects. For energy management, we've identified energy management as one key use case. Mimu mentioned the work that we've done with Smart Grid, and so that makes it very easy to look at those interconnections with the infrastructures of cities. New services are very important. I've already mentioned trustworthiness, and there's a lot of good parallels with the resiliency, safety, and security issues identified in the roadmap for CIB. When it comes to buildings, models, etc., we are very neutral on the business models, but we have a collection of concerns around business to help identify and treat those concerns. So let me now start getting into the broader perspective on smart cities in North America and the U.S. There are growing interests in this area. One way you'll notice that is through many different parts of the United States federal government have come together and are working together. I mentioned the White House Smart Cities Initiative. This is an activity that is supported by over $160 million of federal research, and it involves activities of different agencies, and even President Obama has pointed to the needs of communities. Within our own activities, I'll mention the Global Cities Teams Challenge next. We also have our National Science Foundation, which has done a lot of research funding, but to give you an example of one that is currently of great interest to the cities, we've had many of our cities apply for the United States Department of Transportation Smart Cities Challenge. So this was putting up a significant amount of funding, up to $50 million, to fund one medium-sized city that is making a smart city through transportation, making transportation safer, easier, and more reliable. And they've had 78 cities apply for this particular funding. It will be announced in the upcoming months once they review it. Now I want to talk in detail about the Global Cities Teams Challenge, since I think it's very relevant to our conversation today. One of the things that we've tried to do is to spark some collaborative efforts and innovation with cities working together with technology innovators and other partners. Our idea is that if we can get groups of cities interested in particular issues and problems and have them talk with each other, they can benefit from interactions with technology innovators. But most importantly, this will allow for multiple cities to benefit, and the resulting solutions will be more likely to be broadly applicable, to be replicable in many cities, to be scalable to different sizes, and sustainable. Since we are the National Institute of Standards and Technology, we also have a very strong focus on measuring things, and so we want to see that these demonstrated models have measurable benefits in smart communities and cities, and that's an important component of our most recent Global Cities Teams Challenge. We had started with a version of Global Cities Teams Challenge in 2015, and we're currently in the 2016 component. This gives you a visual representation of the international interest in this. We've tried to make this international. We have many partners within the United States government, and there's an upcoming meeting March 22nd and 23rd here at NIST in Gaithersburg, Maryland, in which the current 2016 participants will present the current state of their project and continue to recruit partners. Now I want to move on to our work to establish a new international working group. We have realized that with the Global Cities Teams Challenge, we've had some insight into how different cities have tackled some specific issues, such as communications and kiosks in New York City, to doing sensor networks to help the elderly in our own local Montgomery County and in cities around the world. This information and understanding of the architectures behind the Internet of Things enabled solutions is going to be very important to help cities understand how to put technologies together. You may purchase items from different suppliers and you want an overall architectural concept that is able to combine many of the advances. Since smart cities technologies are being developed rapidly, and we want to take custom solutions and turn them into more generally applicable solutions, there's a wide variety of these architectural design efforts. What we've done with the partners listed below on the slide is convene an international public working group to look at the architectural features behind the smart cities with the goal of not reinventing anything, not a standards activity. This is more of a description activity to understand a reference framework for the development of architectures for composable smart cities. Our strategy here is to do some analysis of different architectural concepts. This includes things like spyware, IoTA, the Industrial Internet Consortia, and others, and look at how those approaches and architectures have commonality. If we can find some of those common features, it doesn't insist that everything be the same, but it gives an opportunity to identify common pivotal points of interoperability where with some additional work, you could have different architectural activities support each other, and we can use our framework, our cyber-physical system framework, as a way to just map and keep track of some of these important concepts around the architectures. This slide gives some of our time frames. We're kicking off meetings both in the United States right after our Global Cities Tech Jam here in this Gaithersburg, and also our partners in Europe in April are going to have a kickoff for this activity in Rome. And then the process is described here with 3 working groups on applications, the pivotal points of interoperability on the design portion, and then a deployment. So with that, I'll conclude. Here are some contact information that is available. We have a team here that is quite interested in engaging with the broader international community. And so with that, I'll stop and turn things back to Mila.